In this math counts preparation lesson, we're going to be focusing on geometry. So let's get started. We have a square and an equilateral triangle. They have equal perimeters. The area of the triangle is 16√3 square centimeters. How long in centimeters is a diagonal of the square? So we're asked to find the diagonal of the square. If we have an equilateral triangle and the perimeters are equal, so I'm going to call the side length of the triangle x and a side length of the square s. Over here, we have that 4s, perimeter 4s, is equal to 3x. And that's all we know. The area of the triangle is 16√3 square centimeters. Well, we know the base, well, we take half of the base, we get x over 2 times something gets us to 16√3 square centimeters. Well, all that I know is that this height is going to be irrational. Now I'm going to study this equilateral triangle. We're asked for the diagonal of the square, but we don't even know the side length of the square to apply our knowledge of right triangles. Now, if this is an equilateral triangle, all angles are 60. Correct? And then we have x as our side length. Now you should know your special right triangles. We talked about them in the other geometry videos. Your special right triangles, when we have equilateral triangles, we could draw and I'm going to draw a better right triangle so you can see better, but basically we're going to use this triangle to solve the problem. This is 60, this is 60 degrees, this is x, this is x, this is x. But this x isn't going to help us, so I'm going to do something a little bit clever, and what we are going to do is, I'm going to forget the side lengths, we're going to start from this point right here, and we're going to draw an altitude to this point right here. Right angle, 60, 90. This is a bisector. And these two are equal. And we can call these x. X plus x is 2x. Each side length is 2x. We have two 30, 60, 90 triangles. Now, the hypotenuse is double the short leg. The longer leg is the shorter leg multiplied by the square root of 3. Those are our rules for 30, 60, 90 right triangles. Well, now we already know the height. We already know we're looking for the height is what we need to build an equation, right? This height is what we're looking for, not the best line. The height is just x root 3. So when we have x root 3 and these are 2x, so. And I'm going to erase this since we don't even need this equation. We're going to solve this geometrically with a bit of algebra in between. 2x, 2x, the entire thing is 2x. Now this height is x root 3. Now we're taking half of base times height, so we take 2x. We take half of that. The 2's cancel. We have x times x root 3 equals this 16 root 3. The root 3 is a common. And then we have x squared root 3 equals this 16 root 3. The root 3's are just equal. Now we have x squared equals 16. X has to be positive. I've never heard of a negative side length of a triangle, so henceforth x is equal to 4. And if x equal to 4, 4 squared is 16, 16 root 3, x is 4. So now we know the dimensions of this equilateral triangle. The dimensions of this equilateral triangle, well, we can just rewrite 2x as we know x is 4, 2 times 4 is 8. So over here we can write this as 4, this is 4, this is 8, this is 8, and this is 4 root 3 over here. So we know the perimeter of this triangle is 24. Now, if the perimeter of this triangle is 24, the perimeter of this square has to be 24. We do 24 divided by 4, we get 6. A side length of the square is 6. Now, we're looking for a diagonal of the square. From this point to this point, we draw this in. Draw our diagonal. Now, this diagonal is the hypotenuse of this right triangle. Now we know that the side length of the square is 6, since 6 times 4 is 24, and its perimeter has to equal the perimeter of this equilateral triangle. Legs are equal. We have an isosceles right triangle. This is an angle bisector. That means this is 45, this is 45. We have a 45, 45, 90 triangle, and you know the rules for the 45, 45, 90 triangles. The hypotenuse is one of the legs multiplied by the square root of 2. So we have a diagonal of the square is 6 root 2, and we cannot simplify this radical any further. So that is the answer to our problem. We broke our equilateral triangle into two 30, 60, 90 triangles. And whenever you want the height of an equilateral triangle, break it up into two 30, 60, 90 triangles. And always use special right triangles to your advantage. And if you did not understand why this is times the square root of 3 times the square root of 2, you should watch the special right triangle videos, which you should be watching all the prerequisites to the math counts preparation lessons.